was a photo. No. Good evening, YouTubers. I wanted to show you something I've been working on for the last couple of weeks, and it's a project which will allow me to transmit both power and data wirelessly, that is, through space. The range isn't great, probably a couple of inches, but you can improve that by using bigger coils, tuning the circuit. But for what I want to do, I want to use it for a persistence efficient display or a POV display, and it's fine for that. So I'm going to just show you how it works. We've got here the transmitter section. Actually, this is the transmitter. This is responsible for transmitting wireless power. So we've got an inductive loop here, tank capacitor here. This forms what you call an LC tank circuit, which is a resonant circuit. This is a driver for it. This is what you call a zero voltage switching driver, or a Royer oscillator to give it its proper name. Basically what that does is that this switches these MOSFETs during the off part, during the zero voltage part of the waveform, which means that you don't generate hardly any heat in the MOSFETs. This is hooked up to obviously a power supply here. It's giving me 12 volts, 5 volts, and this is the logic portion of the transmitter, and this is responsible for transmitting the data. So what we do is we modulate this, which generates 2.2 MHz carrier wave. We modulate this using a MOSFET, which you can probably just about see here. Switch using a totem pole driver, and it's controlled by this little tiny 45 AVR part here. This is running an Arduino sketch, which uses the software serial class that comes with Arduino. And it modulates the carrier wave which this produces, and you can demodulate it here to get your data back out. So this is the power supply. This is the receiver section here. As you can see, we're feeding the about 30 volts peak to peak AC from the coil and capacitors and another LC tank. It's obviously tuned to the same frequency as the primary. Feeding that into a bridge rectifier here. Feeding that from the bridge rectifier through a diode. This is power supply section. This is a 5 volt regulator. This is a smoothing capacitor, and that gives us a nice clean 5 volts there. Now, before we go into the smoothing capacitor and the regulator section, we're actually taking a signal just after the bridge rectifier and feeding it through some resistors and capacitors, which demodulate it, and the voltage regulator. This isn't ideal, but this gives us a 5 volt square wave which we can feed into the Arduino. The Arduino here is running a receiver program I wrote, which again uses software serial, and it takes a signal and turns it back into data again. So I'm just going to demonstrate it here. So I'll switch on the power supply like that and power up the circuit. As you can see, the range is probably not too bad. And just put that there to just give it some separation. Plunk the receiver coil on top, and that's now getting power, as you can see by the LED. Now if you have a look at the Arduino here, you can see it's transmitting what it receives from this side of the circuit over to the computer. So I don't know if you can see that too well. You might have to zoom in on that. Yeah, there you go. So you can see it's sending hello world, and it's sending it completely wirelessly. So there we go.